I, in this session, we'll try to understand what is AWS EKS, where that is Elastic Kubernetes Service. Okay. So in previous session, we have already come across by that is ECR, that is Elastic Container Registry, as well as Elastic Container Service. We saw how to deploy an application in container service and how do we access the things. So here we have some advanced features compared to container service, that is Kubernetes service. So we'll go and try to understand what exactly the EKS and all. Fine. So the agenda of the session we're going to cover, that is what is EKS and why do we use EKS, how does an AWS EKS work, and when it comes to Kubernetes, having the knowledge of deployment service is quite more important, and along with that, Helm is added one. Fine. So, component of AWS EKS, that is, what are the things we can get inside the AWS EKS and some example scenarios. Fine. Okay. Now we'll move on. Okay, so now we'll try to understand what is EKS, that is Elastic Kubernetes Service. Fine, is a managed Kubernetes service provided by AWS. So when you saw the word called managed service, think that it's completely elastic one. That is, you can scale up or scale down automatically, which is taken care by the AWS. Fine. So you don't have to manage infrastructure. So just you need to create your own service, whatever you have thought of deploying the application. So REST, provisioning, auto scaling, load balancing, security, networking, everything is being taken care by the AWS. That is why they name it as like a managed AWS service. Okay, so that simplifies running Kubernetes on AWS by automating tasks like, so the Kubernetes will help us to automate the task like controlling plane management, patching, that is security, updates. If you have any updates, that is, if you want any new application, that is, you can go and deploy it. And another one is EKS, that is Elastic Kubernetes service that ensures high availability and secure Kubernetes environment. So whatever the application we going to deploy inside the Kubernetes service are highly available to the end users, so without any logs, and even they provide more security. Fine. And that is secure Kubernetes environment without requiring user to manage the underlying infrastructure of the control plane. So you don't require to manage each and everything. So fine. So even when it comes to security things, or when it comes to managing the networking or accessing things, proxy cards, we do have the proxy cards like and canary deployments, right? So those will be taken care by the Amazon itself. Fine. So we just understand what is EKS and why do we require it and how it is going to benefit of us by deploying our application inside the Kubernetes environment. Okay. So now we'll understand, we have already come across few keywords why we required EKS. So we'll move into dive. Okay, so managed Kubernetes service, that is, we'll try to understand what is managed Kubernetes service. So we saw here managed Kubernetes service, right? So EKS handles Kubernetes control panel task, allowing you to focus on deploying and managing the application. So only you need to keep an eye on deploying the applications and managing the application like versions things. So rest will be taken care by the AWS. Next is scalability. It allows seamless scaling of containerized applications. So based on demand. So if there is a huge traffic targeting your application, so you require to have more infrastructure, underlying infrastructure. That is the configuration required more. So even by analyzing the traffic, it will go and scales up automatically. And integration. So you can integrate AWS, that is EKS, with other AWS services like CloudWatch for monitoring the logs and all, and also IAM for allowing the permissions. We can maintain the permission, and you can maintain the private or the own network, fine, and more for enhanced monitoring and security thing, security as well as networking, fine. So these can be integrated. So high availability. Next is EKS provides multiple availability zones for control plane. So when they say your application should require high availability, so if you are deploying on the single subnets or the zone, so there won't be a much availability. So even EKS supports multiple zone availability. Fine. Next is compatibility. So supports native Kubernetes tooling and workloads. That is what exactly the base Kubernetes applications have the features or the tools on the command. Same can be used here also. So there won't be thing like you don't require to learn many things additionally. Fine. Next is how does AWS EKS work? So we just understand why we require. So now we'll try to understand how exactly it will going to work. We just understand what it is and why it is. Now we'll try to understand how. Okay, next we were seeing some words like control panel. Now we'll go and understand what exactly is all. So EKS manages the Kubernetes control plan, which consists of components like etcd, that is elastic directory for storing cluster data. So there is a pod called etcd. So whatever the things we going to deploy, so those script should be written in the YAML file, and that will be stored in this pod or the cluster data. And Cube API server. So we will be using Cube API server to interact with the work node, or sorry, work node or the other pods, and pods wants to communicate with the main cluster or the control planner. In that case, also the API Cube API server will be doing. So it's a center one who interacts with the work node as well as control panel. Okay. So for mapping the API request, fine. Next is worker nodes. So the user provisions EC2 instance or Fragment as a work node to run Kubernetes pods. So either we have two kinds. So one is you can just deploy your own server, EC2 server, and install the pre-requirements like Kubernetes, Minikube, like things, and you can deploy the application. Or if you are going with EKS, so they are provisioning the two things. So one is you can just go and create the EC2 instance. So inside EC2 instance, the things will going to happen. So it's a kind of manual thing I just mentioned, right? Another one is Facret. This is the serverless server, so which can be used for deploying the application C using the EKS. Okay, next is communication. So worker nodes communicate securely with the control plan using the certificate as well as secure endpoint. So each and everything is being taken care by the API server, and which is managed by the AWS. I mean, with regards to security things. Okay, next is cluster management. So user interacts with the EKS cluster via kubectl or AWS CLI. So we can able to interact with the Kubernetes or the EKS cluster either from the CLI mode or the console mode, or yes, only the two things we can go ahead with by accessing things. So kubectl is nothing but they need to get the things from CLI itself. Another one is console mode. Okay, next is deploying workload and managing the resources. So once we are able to create or interact with the EKS, so we can deploy the application workloads and manage the resources. Okay, scaling. So next is EKS scales applications automatically using the Kubernetes built-in features like horizontal pod autoscaler. So here they will be using the horizontal pod autoscaling things. So they don't go and create the new thing. So automatically the existing one will be the right. So automatically the things will be upgraded, or the configuration of the infrastructure will be upgraded. So you just understand how it is going to work. So we'll be having the control plane, so where the main Kubernetes cluster will going to control all the work nodes. So our communications are made from this. So how we can able to access the either control node or work node from the cluster, that is through cluster management, that is UI as well as CLI. Okay. So we just saw, we were speaking about like mentioning something and all, but we did not um, heard. So I was just mentioning the deployment thing. So where should we deploy? How should we deploy? So we were just mentioning pods or the Docker containers or the container like things. So now we'll understand what is deployment and all. Okay. So the deployment in Kubernetes is the resource that manages the desired state of your application. Like, so the deployment is a kind inside the in Kubernetes. So is the resource that manages the desired state of your application. So inside the deployment or the YAML file, so we going to define so what should be my application specification things, so where I am deploying everything. Okay, state of your applications, it ensures that the correct number of replicas of your applications, that is so before we deploy inside the Kubernetes, so we will be having the containerized application, that is the Docker, right? So Docker container we will be having, right? So that container, so while we are deploying the things inside the Docker container or the Elastic container service, so we used to have the single container. So when it comes to Kubernetes, so we can have the multiple containers inside the single pod, like inside a box. So we can have the multiple, that is same application with multiple replica, so that it will be highly available. So the request, whatever the requests are coming, are distributed under the available containers inside the pod. Okay, so where we can mention the number of replicas, that is how many copies of your containerized application needs to be created inside the pods. So that is the replicas will be mentioned are running and automatically replaces failed or outdated pods. So we can mention like replicas followed by the so and so number. So that number of application or the container replicas will be running actively. If any one of it fails, so automatically it will be regenerated or the recreated. So when there is a fails occur, so the API server, that is the worker node, will intimate the API server saying that so the container got affected and it got turned out. So kindly provision as the new container again. So the API request will be made, and from ECTD, I just mentioned, right, in this cluster data. So from it will fetch the file, that is YAML file, and it will going to create the another container to maintain the replicas value. Okay. So here we have some key features that allowing rolling updates or rolling back for application version. So we can release the updates also by, that is by doing the kubectl apply followed by the YAML file, name of the YAML file, or we can roll back the things and then scaling the application upon the. So these can be managed from the deployment and ensure application pods are healthy as well as running. Okay, so it will going to ensure the health of the things. Okay, next we'll try to understand what is service. So in Kubernetes, we have another kind. We just come across one kind, that is deployment. So where we going to mention the configuration and the number of replicas and the health monitoring system, everything we saw. That comes under deployment file. So we can have the another file, that is service file. Why do we require service file? The service in Kubernetes is a networking abstraction that exposes a set of pods are in single network endpoint. So here we have created the three container, right? Assume that the replicas I am talking right now. So replicas in the sense, so how many copies of same application should be deployed? So let us assume. So right now I have the web application or the microservice of login thing. So I will be deploying three copy of the same page. Okay. So while accessing the thing, so the three application will be having the three different IP addresses. So once I just refresh the thing, it will be navigated to some IP address. Once I refresh the thing, it will be navigated to another IP address. It would be quite trouble one, and it's very hard to access or to maintain the data things and all. Okay, so when new like some in among three, one got failure due to some disaster thing. So the new one got updated there. So in that case, again I need to update the IP address in my DNS, or else I could not able to access my application. So to overcome all those things, so we will be having the service file. So where service file will help us to maintain the availability of the application. How it is going to maintain? So the replicas will have three different IP addresses for each container, right? So they going to merge and they going to generate the single IP address like load balancer. Okay, so the networking abstractions that exposes the set of pods as the single network. So the set of pods altogether, it will going to create this single network endpoint. So if you get that IP address, you can able to access the content which are deployed inside the pods. If you have deploy or if you have the replicas of three or four, it doesn't matter. So if you have the service IP address on top of the deployment, so you can able to access the things. So it provides the stable IP address and DNS names. So this is the best practice or the best way to why we switch from container service to Kubernetes service. This was the main reason. So we will be having the stable IP address along with the DNS name, that is it acts as a load balancer. And VDQ can have the number of replicas to maintain the high availability of your application to the end users whenever they are accessing. Okay, so even if the underlying pods changes are restarted automatically, the address will be updated in the service, but there won't be any changes in the stable or the service IP address. Okay, so types of service, one is cluster IP default one, so expose the service within the cluster, so which can be accessed so within the cluster. If you are within the cluster, you can able to access the ports. That is, one is node port, exposes the service on the specific port on each node. That is, node port is used to expose the service to the end users on the particular port. Next is load balancer. Expose the service using the cloud provider's load balancer. So it will going to create the load balancer if required. Next is external name. That is maps the service to an external DNS. So if you want to link to any other external DNS which you have already been purchased from the other domains, so you can go and link there also. Okay. So this is the kind how we going to deploy our application inside the Kubernetes. So these two are mandatory, and This is how the actual applications are being deployed in the Kubernetes environment. Okay, and we do have another something like what is Helm. So Helm is the package manager for Kubernetes that simplifies deploying, managing, and updating Kubernetes applications. So it's a package manager in the Kubernetes we have been used. So why do we require it? So to deploy your application or managing your application or updating your application, for all those things we will be using like this. It uses the chart, which are collection of YAML templates. So we have written the files, right? So one is deployment file, another one service file. So based on the content of the these files, so it will going to create as the chart. Okay, so to define the resource need of an application needed for the application, so it will going to decide so how much requirement is required based on the image as well as the configuration we have written on the YAML template. Okay, so key features, that is package manager in Kubernetes resources into reusable and shareable Helm charts. Okay, so we can, once it is being created, we can reuse that, or we can share to other engineers too, for if they have the same configuration things. Okay, so allows parameterization for configuration for different environments too, and supporting upgrading and rolling back application version. So complete management of your applications can be done by doing the Hellman's package manager, by using the Hellman package manager. Okay, so this is why we use Helm package. So this needs to be installed additionally in your CLI. Okay, so we just understood from initially, that is what is EKS and why do we require, how it is going to work, and how do we deploy and how do we configure our application and all. I will go and show you the example also, don't worry. Okay, so how the file will look like, I will show during the demo sessions. Okay, next, components of EKS. So probably we are speaking about the control plane or the cluster, right? So the cluster or the control plane will contain these many parts, that is pods. Okay, one is we saw like Kubernetes or kubectl API servers and etc for storage. The scheduler will go to schedule when should be event should be triggered, and the controller manager, and that is the first pod will be control plane. Okay, so inside that we'll be having the API server, that is handle RESTful API request from user and external tools like kubectl or L1. So any request we made will be traveled through this one, this pod, that is API server. Next pod is etcd, that is a distributed key value store used to maintain the state of Kubernetes cluster. So whatever the data we will be passing, that is the YAML files, right? That is deployment, server, load balancer, like things. So those data will be stored in etcd for further use. Next is scheduler, assigns pods to nodes based on resource requirement as well as constraints. So based on API server, it will going to assign the pods to nodes on the row, that is a resource requirement as well as with constraints. Next is controller manager. So ensures desired cluster state by managing the controllers. That is, it will going to manage the all the pods like a node, replica set, deployment controller, everything. So whatever we have written inside our YAML file, that is number of pods or the replicas application we have mentioned, right? That is, and the load balancer and the deployment controller, like things. Okay. Next is worker node. So this is the worker node where we actually going to deploy our application. So here we will be controlling only. So the where worker node will help us to deploy our application, and whatever the request we made will not be proceed or will not be accepted directly by the worker node. It should be come to control plane. From there the proxy server will be there, and from there it will going to proxy server, from there it will going to work node things. Okay, so if you want to understand all these things, so just go and watch the service mesh concept so he will be understanding more. So before that, try to have the basic or the core knowledge of Kubernetes. Okay. Next is that is worker nodes. So in worker nodes, we have already mentioned that into manner we can go and deploy the things or the infrastructure. So we need some infrastructure, right, to run our application. So these are the two things. Either we can go with manual one or we can go with serverless. Next is kubelet, that is the agent on each worker node that ensures pods are running healthy. So this is the agent pod which will be maintained in each worker node. So who is going to take care of the pod's health? Okay, next is kube proxy. I was mentioned, right? So whatever the request if you made, it won't be getting inside the server directly. So it will be traveled to two different pods and then it will reach to server, actual server. So even while responding back, the same thing will be happening. Okay. So manages network communications for pods as well as service. Okay. So this is the proxy thing which going to manage the communication between the pods. Next, container runtime software like containerite or docker responsible for running the containers. Okay. And next component is networking. So networking in the sense we will be creating and deploying inside the private or the VPC, so which will be isolated from the outside world. Next is container network interface, manages networking for Kubernetes pods. So we will be having the pods right inside the Kubernetes cluster, so that cluster will be having its own network. Next is IAM as well as security will be provisioning the permission who can access, who cannot, like that. Next is monitoring and logging. We'll be using CloudWatch when we are going with the AWS, or when we are going with Kubernetes, we'll be going with Prometheus or Grafana, the common open source tool for monitoring the Kubernetes workload or the logs. Okay. Next is add-on. That is AWS offers Kubernetes add-on like core DNS for service directory. So sorry, service discovery. So here also we can able to identify the new cluster which is created, and the same thing will get updated by itself by providing their IP address. Newly generated IP address will be associated with the DNS or the load balancer. That is okay. So next is example scenario. Assume that we'll be having the application architecture, that is the microservices of four things. One is auth service is nothing but your login credential. Next is product service, that is your catalog. Order service, that is your cart. And the payment processing thing, analytical service, track reports, user behaviors, like this. So each microservice run in its own Docker container image. So we need to have initially the Docker container image for each of these microservice and should be pushed to the Docker or the Elastic Container Registry. Okay. So from there we can pull the image or the Docker containerized image to the Kubernetes. Okay. So before that we need to have the cluster. So why do we have the cluster? So where we need someone to monitor all our workload, right? For that purpose, the Kubernetes will be having the cluster using the AWS management console or the CLI or the automation tool like Terraform. So create the EKS cluster. So once we are done with creating the main server or the cluster, provision the worker node. So from now onwards, we'll decide. So where should I deploy my application in the work node? Whether it should be going with manual deployment or the serverless. To create work nodes, these nodes runs the containerized microservice. So here where actually we going to deploy the microservice. So how we going to mention that the thing should be worked in this ecosystem? Some through the EKS, that is etcd we have, right? So there we have stored the file which we have written. So from there it will take from the scheduler as well as the with the help of API server, it will go and create the things in the either Facrate or Amazon EC2. Next, when it comes to networking, so that is we can have the service that is load balancer or the cluster IP thing, and I'll use the AWS VPN and all the things. Okay, next is deployment. So I just mentioned, right, Helm and chat or the we can either go with Helm and chat so which is already been defined, so based on the previous workloads. Or if you want to go with custom, so either we can go with the YAML files are used to define the deployment of each microservice. That is, we need to write each YAML, that is different YAML file for different microservices. And there in deployment will be mentioned in the replica, that is how many copies of the same application you required. And horizontal pod autoscaler, that is automatically scales pods based on the CPU as well as memory usage, we can be define that also. And when it comes to storage, elastic block storage for persisting storage where needed, that is product image like that. Or we can store the data in the s3 also for analyzing purpose. And we'll be using the IAM roles policies, which will we can do all the customization things, and who can access what and who cannot access what we can be defining here. Monitoring and logging will be using the CloudWatch or the Grafana if you're going with Kubernetes dashboard things like that. And to automate, we will be going with CI/CD things. That is, the code pipeline will be the bridge to link from your GitHub. From there, it will be going to code build. From there, it will going to deployment. Okay, so this is all about the EKS working. So we'll try to understand from the demo. Okay, so before we get into the demo, so make sure that your local system will should have the pre-requirements like this. So install the Python. On top of that, install the CLI, that is AWS CLI to interact with the AWS, and install the kubectl. So this is the command. So that is the Kubernetes command. And if you want, since we'll be using the CLI to create the EKS, we require to have this also there on the package manager, or to import the chart of my application. Okay, and also create the IAM role with the proper permissions. Okay, so once you are done with all these things, so you can go and deploy the application. We'll go and try to see that. Okay, now we'll go and look into the practical or the demo on the Kubernetes service. So before we go ahead into this, I have priorly created the root IAM credential, that is access key as well as private key. So just okay. So from console, just type EKS, or you can just type the Kubernetes service also. Okay. So now, since we have two ways to create or manage the Kubernetes cluster, fine. So one is from by doing manually, that is creating by entering the manual values, or we can directly go ahead with CLI mode. Even that could be fine. So whichever is convenient for you. Okay. So here they are taking the default VPC. So if they are not, I mean, if you want to create with the custom one or the different network, you can go with custom VPC. So just look at here. So I have not created any cluster over here, so we'll try to refer the document. Just click the documentation section and navigate to user guide. Fine. So here we have a setup thing, quick start. Fine. So prerequisite, they ask us to be installed, that is set up AWS CLI and configure credential. So install EKS CTL, then install kubectl things. Fine. Okay. So to install EKS just open new tab and enter EKS install. Just go to installation thing, the first link. Okay. So from here, just scroll down. Here we will see that the steps to download for your Unix environment. Okay. Just copy these and paste it in your terminal. So here I will be using the WSL, that is a Ubuntu based system for the command line interface thing. I'm not using the Windows one. We'll enter this. So it's working. You can see here, and it's prompted for password. Okay, it's done now, and we are done with installing the EKSCTL. Now we'll go and install the kubectl. So EKS, for doing any interaction with the Elastic Kubernetes service, that is the AWS, and inside that we are morely used into Kubernetes, right? That's why we require the agent, that is the kubectl we'll be using. So just copy this one and paste it. Okay, now we are done with the things. Now we'll validate the. Okay, we'll go and download the binary also. It's required to run that. The procedure will take some time. We pause the session till it gets installed. So now the binary file got successfully installed. Now we'll go and check whether the files required dependencies are available or not. Okay, now it's available, and now we'll go and install the kubectl. We have just downloaded the files. Now we have installed the kubectl thing. Okay, now we'll check the version. Yes, it should by the end of the installation you should be able to make all this. Okay, so now we are done. So if we are using the Debian based distribution, so we can go and install the things like this also. That could be. So now we are done with installing all these three. That is previously I have done with the AWS CLI. Okay. Now next they are asking us to configure the cluster. Fine. Okay. So now we'll go and create the file and we'll run this file too. As of now, we'll go and follow the procedure here. If this doesn't work, we'll go with another thing. Okay, we'll clear the screen. Fine. Okay, right insertion. We need to update few things here. In which region I want to create the cluster? Okay, that is Europe, North one. Fine. Rest looks good. Replace region code with the valid region such as. Okay, so now we are good with it and we'll exit this one. Okay, now we'll go and before we go and run the things, so just confirm whether your AWS CLI is integrated with your terminal or not. Yes, it's there. We'll run that file. That is the YAML file. So now it is been provisioned. So if you want to know what exactly the things is happening means just navigate back to the AWS console from here. Just go for the cloud formation so that we can able to navigate the things what is creating where and all. See here, create in progress. That is EKS the name of the cluster. We can just refresh this one. See, so till that you just go and create this one. Fine. So next they're asking us to create the Kubernetes ingress class for EKS auto mode. Okay. So here we will be creating the load balancer thing. So EKS Automotive uses the Ingress class to automate the provisioning and managing the load balancer. So integrating your Kubernetes application with AWS load balancer service. So again, we need to create the another file. So it will take some time. So it needs to create your VPC and the supporting, that is a EVL for the storage thing and the server. Everything it needs to be created. Fine. Just I have provided the name as well as region. So rest of the things is being taken care by the AWS. So since we have done through the CLI, so if we are going with the dashboard mode, that is the console mode. So on that case, it will be completely different one. Okay. So the overview, that is okay. We go have encountered some error and we'll go and try. No, things are going good. So we'll wait till the creation. It's till there. We just go and try to understand what exactly the application is all about. Okay. So here they have used the namespace, that is game 2048 is the namespace or the ecosystem they have created inside the Kubernetes cluster. Okay. So whatever we are going to deploy, we're going to deploy inside this namespace. That is the namespace value refers to game 2048. Okay. So below that, again we have mentioned the, this is just we have changed the directly like things. Okay. So as this is actual thing, we have mentioned the kind deployment and the namespace. In this namespace, the deployment should happen. That is the tags or the metadata. I can say that here is selectors. Here they are matching the labels. That is app.kubernetes.io fold, right? It will going to refer to the namespace like this. Okay. And here they have taken 5 replicas of the containerized application, whatever they are defined. So template, this is one, and here is the container specification. So here is the name of the container or the address to the container URI, and image pull policy is always they have mentioned and where they are deploying here, and the port 80 will going to expose to the outside the things. Okay, so on top of deployment they have to require the service, because each container will have the different IP, so it's quite hard to access the thing. So for that we need a load balancer to merge all 5 containers into one IP or to get the one IP address like things. Okay, next here also they have mentioned the ecosystem or the namespace. Here they have mentioned the ports. That is actual port is 80 as well as targeted port is also 80. Protocol they are going with TCP, and the node type is node port, and the selector, that is the selector will is the match label. Okay, and thereon they are allowing the, that is all ingress in the sense incoming traffic. So they are writing the traffic rules, like from where the path should be at, like all those things. Okay, so this is what exactly we going to run once all these installations get done. So it will take at least 5 minutes to create all the thing. So fine, now the things got successfully created. We'll go into the console and we'll verify that once again. See here, the states from creating it's get updated to the active one. So we'll just look into this. So as of now, we have just created the cluster and we have not created, we have not deployed any pods or the application. Fine, that's why it is showing like upgrade insights is zero, cluster health is zero, node health is zero as of now. So this is the overview. If you want to access the things from different load balancer, on that case, we can go and this one OpenID Connect provider. Okay, so the resource what it has been created, like the replicas, pods, everything. So cluster nodes. Okay, so the compute is still it has not created anything because we haven't created this file, right? Ingress class. That's the reason. Okay, so let it be. And the networking part is completely related to the VPC as well as accessing thing add-ons if they have the access configuration thing, observability. Okay, so now we'll move on with the next step, that is creating this file. We'll clear this one before. We'll copy this, paste, and no modification is required. I will go and run this file too. Yes. Okay, now we'll go and deploy the application as per the instruction provided in the documentation. So here we just now created the things, and here I have created the namespace or the ecosystem. Fine. So now as per their instruction, I could able to see that is namespace game hyphen is being created, and now we'll go and deploy the thing. Actual deployment is now happening, like the pulling of containerized application and creating the pods, cluster, IPs, everything. Okay, see, now these things got created. So where it is created, let me show you people. Just refresh the things. So initially the insights was 0, now it's been 3. Okay, now if we go to the compute. Okay, now we'll come back to these replicas and yes, the deployment. We have just done the things, right? So still it's under creation, and how do we check whether it is created or not? Okay, so for that, kubectl get ingress. So we are just checking the ingress port here. We are not checking whether the process is creation or not. We'll go and check that also. Okay, now the things, and yet another thing I need to show you people. So initially we have not created any, we have wasn't having any load balancer. Now we can able to see the load balancer, right? And if you want to see that whether your pods are creating or not, you just type sudo kubectl get pods hyphen n, that is sorry hyphen name n, that is name stands for n, and the namespace. So in this namespace, what are the pods is getting created, we can able to see that by passing this command. See here. So the deployment, these are the things which are getting, and it's been created and one by one. So whatever this is the maximum the resource having, and the same number should be present over here. If not, something has went wrong like that. So you just copy this address, that is the load balancer address, and paste in your tab. So no, not here. Here you should be able to access the application. Okay, so you can successfully able to access the application. We'll hit new. So join the numbers and get 4028 things. So use the arrow thing. So you can play. So probably you people have just understood what we have done so far. So nothing much we have done. So if you have the basic knowledge of Kubernetes, then you could able to understand what we have come across the things. If not, just go back to this channel and find the Kubernetes tutorial, and you will be able to find out things. So just now, that is we have installed priorly, that is AWS CLI or the configuration thing. So through this, from that IAM role, we will be creating the instance or the EKS one. Okay, so for that we require the permission. So the permission needs to be provided in that user itself. Okay, once after done with that, so just navigate back to your terminal and hit AWS config. If it is not working, just go and install the AWS configuration thing. Type AWS CLI install. Okay, so just go to this first link. Fine. So AWS CLI install and upgrade instruction. So based on your environment, you just go and install the things. So once you are done with that, install the EKS. Just search install EKS in the search bar, and you will be able to navigate to that and install that as per the procedure. The same for the kubectl. So once you are done with these things, you need to configure the cluster. So you have two methods. One is from the UI or the console one, or one another one is the CLI mode. So either you can go and write the YAML file to create the cluster, or you can go and just have the inline command, that is the single. We have the single command, you can use that also. See here, EKSCTL, that is elastic container, sorry, elastic kubernetes service control create cluster. So we are passing the command to create the cluster hyphen name. So what is the name of your cluster, just provide here, and hyphen region, in which region you want to provide, and whether you want to provide EC2 or Fargate, you just mention here. That's it. So the same thing they have done here. So here kind of cluster configuration, here we have just created the cluster, and metadata, that is name of your application or the cluster. Here the name of the cluster is demo EKS, here it is web quickstat. And region, here I have mentioned the region. And auto mode configuration, they have enabled it. If you want, you can just go ahead with that. Okay, so once after creating the cluster, and if you want to configure the Fargate, sorry, Fargate. So on that case, this is the command to go with it to create the Fargate, and always make sure to use the namespace. So this is the namespace we going to create with inside the Fargate. Okay. So once after that, we just go and deploy the things. So here we just done with the ALB, right? Suppose that we go and deploy this one. So it's a quite long procedure actually if we are going with. So for that purpose, I just done the demonstration whatever we have in the documentation, so that it will be easy for you people to understand and do the performance also if you did not get any of these comments. So that's the reason I have gone through the documentation demo itself. Fine. So once you are done with all your things and you thought of okay, so you have either you can just come here and hit this delete button. So to deprovision or to delete the resources, whatever the resource we have been created. If not, you can just go here also. You can just take these till there. Okay, so let this run also. Just select this one and delete the load balancer manually. So post done of your practice or the hands-on things, always ensure to delete the resources. Fine. So you need to check all the EC2 instance things, that is the target, everything, and delete accordingly. Okay, now we are done with target and this one. We'll go and check whether the auto scaling has been created or not. Okay, elastic IP is not required. Key pair is also not required. Okay, elastic IP is also being created. For this, you will be charged. Okay, so just disable the things. Okay, or else once we are deleting the EKS, simultaneously it will get deleted here also. Don't worry. Okay, so we'll check for the snapshots. Don't have volumes. Don't have. Okay, launch template. Okay, now finally we'll go and check with the instance. So the things is terminated, because why it is got terminated here, delete in progress. Okay, so that's the reason. Just we'll go back here and we'll look in the compute section. So if we have any target profiles, okay, we do not have. Just click on the delete and wait whether the delete progress will take place or not. Okay, so the termination is being processed as of now. So for installation things, it will take hardly about 30 minutes to 45 minutes, completely depend upon your hardware things. Okay, so post that the deployment thing you have just referred the documentation, right? So it will take another 15 to 20 minutes. Okay, so try to perform this and you will be more familiar with the things. Okay, so cluster not found. So the cluster got deleted successfully. Okay, so now we'll go and check with elastic IP. See here. So automatically when the cluster got terminated, so the things also got evacuated from the place. Okay, so we'll go and see the security groups. Even that is has been created, deleted. We'll check here also. Okay, the things are good. Okay, so post performing of demo, always ensure to recheck or the cross check the things which you have done. So you should not able to see anything that related to EKS here. So this status should be delete completed. So when you saw this status, you can just move back to your console and log out from your things. So this is all about the AWS EKS, that is Elastic Kubernetes Service. So we just come across many things that we understood why what is EKS and why do we use EKS, what is the advantages of migrating from Docker or the container service to EKS, and how we going to deploy the things, right? And we saw some example as well as the demo also I have explained you. the things, that is what exactly the YAML file will look like, and what are the configuration we going to enter there on all. Okay, so thank you all for being a part of this session.